In this tutorial, we're going to make something like this, where we can animate a piece of geometry merging together like this. So this is useful if you're doing sort of developmental biology, so formation of the heart or something like that, where you have to have structures merging together over time. And so this is a very simple setup, but it could be adapted to other things, although I suspect that the more complex you get, the more difficult it'll be to manage, but I'll show some of the principles of what we're doing here. This is using the Bifrost Graph to Boolean these things together by converting it to a volume, then back to a mesh. So before we get into the Bifrost Graph, there's just a couple of things to look at. There are ways you could do this with sort of standard Maya, and especially now that there are volume booleans. So just as an example, I'll just show this quickly. If I create a cylinder, make some subdivisions, and I duplicate that, and just delete the error history and freeze their transformations. If I overlap these two things and select them both and go to Mesh Boolean, and I'll open up the union box. So by default the geometry mode is mesh, and so if I do that, then these things are just combined. Actually, they're more than combined. They're actually attached to each other, so they're the same shape node now. But if we go into the Boolean node, we can change geometry type. Geometry mode from mesh to voxel. And now you can see it's doing something different. We can see these, that it's a very rough approximation of the geometry. And that's because it voxelizes the surface. So essentially it kind of fills the object with voxels, so 3D pixels, just cubes, to approximate the space filling nature of this inside and on the shell. And if we turn down the voxel size to 0.5, you can see it's approximating the shape a lot more closely. Go down to 0.1, and then it's doing a good job. And now this is sort of an ideal scenario where we've got two shapes that are very similar in terms of density and shape. So not one isn't really short and squat, another one really long and thin, because the voxel size has to work for the whole thing, right? If we go back to the original cylinders here, I'm just going to hide them so we don't have to see them, but I can still select them. So I can select polycylinder 1, and there's history, so I can move them. So we can kind of get that merging action. If I rotate this, kind of getting that to work here. But if I take it, oh, it actually works really well. Okay, so this is one way to do it. It wasn't working for me before. Before, when I totally separated them, then one side would disappear. But anyway, so this way can work. And if we just change it to a slightly higher value, then we can smooth it, select the original object, and we can get pretty nice results of these things merging together. So that's a good way to do this. Who knew? But what we're going to look at here is a way to do this using the Bifrost Graph. So if we go to Windows Bifrost Graph Editor, I've got it set up here to the side. You can see that this thing that I have here is set up in a pretty straightforward manner. So Bifrost is a visual coding environment for Maya. It sounds easy, and it probably is for people who know a lot of these things. I find it useful, but I'm often just sort of whacking my way through it, trying to figure it out. But essentially what we've got here is I brought in two pieces of geometry, and let me just show them here. So just two pieces of geometry, and I've just got them animated. So they are deformed along a curve using curve warp, and those two curves have blend shapes on them that just change their shape over time, like this. And so it's these two pieces of geometry, branch L and branch R, that I'm bringing into the Bifrost graph editor. So I'm just bringing them in, and then I'm performing just a few functions, and I'll rebuild this in a second. So we're turning each piece of geometry into a volume, so mesh to volume. Then we're merging those volumes, and then we're going back from that volume into a mesh, and then we're outputting it as a mesh. So this works pretty easily with two, but if we had another piece of geometry, we could easily add that here and then just pipe it into this merge volumes. So let me just rebuild this. I'm just going to break these connections and put this off to the side, just in case I forget. And we'll take these out too. So I'll create a new graph here. So there's my old one, here's my new one. And it starts with this, with an input and an output. So the input we don't really need. We can just delete this and bring our own shapes in. So we're going to bring branch L in. I'll just middle mouse drag it in, and branch R will come in too. And we want to convert each of these into a mesh. So if you hit tab on the keyboard, it will bring up this contextual menu. And if we start typing mesh to, and we'll see volume. So the two that we can use here are mesh to level set and mesh to volume. Those are both things to create volume. So let's try with mesh to volume here. And I'm just going to duplicate it. Nope, that is wrong. We are just going to copy and paste it. So we'll take the mesh output from the branch left shape and go to the mesh input of mesh to volume. And then we'll do the same thing here. So let's hide our branches and our curves. And let's hide this Bifrost graph that I created earlier. Okay, so we don't see anything yet, and that's because there's nothing to show. If I hooked this up to the output here, then we would see that one volume, right? So there's the volume that was created. So now we want to merge these two volumes together, and we'll look at the different settings here in a second. So we'll just say merge volumes. And then you can see the input node here has got these three dots. This means it can accept more than one. So we'll bring a volume in, and then we can bring another volume in, and we'll create new input ports. Now, we can hook this up to the output here, or we can just turn on preview, and then we can see a preview of the volume that's created. And then we can add one more node. It's volume to mesh. And we'll just attach that there, and we can preview this so you can see what we're getting here. So let's change some of our settings. So if we go to the initial mesh to volume from the branch left shape, so that would be this one here. Let's take a look. So the volume mode is solid. We switch it to shell. I don't think we'll see anything different here because this has got a cap on it. It might actually be hollow in the middle when we change it to shell. We can change the thickening, so that does what it sounds like it will do. And the offset does something similar. It's just offsetting it from the surface. By default, this comes in as store fog density. I'm going to switch this to store level set. Then we'll do the same thing for this one down here, so they're the same. And then we can go into detail size here. So we want to leave the resolution mode at relative. If we change it to absolute, then it will be related to the scene units. So we can just leave the detail size or the resolution mode at relative, and we can dial up and down the detail size. If I turn on wireframe on shaded, we can see what it looks like here. And in a case like this, we might actually want to have the same value going into the detail size for both of these nodes. And I'm not sure the best way to do this, but I would just make an external node for this. So here in mesh to volume resolution, we'll just open this up. And there's the detail size, and it's got an input. If I just right click on this, we can say create a value node. And it will attach just an empty value node with that value in there. And then I can connect the same thing to the detail size in the other one. Just drag it down. So now we can just change it in one place. So we can say 0.03, and then they'll both change together. So just kind of a quality of life thing. So we don't have to make changes as we go. And I'm sure there are a lot of other more efficient ways to do a lot of things in here. So we can go through and change these values here, but I think it's mainly the detail size that we want to change. And we can change the thickening and offset, I suppose. If we go to the merge volumes, then you can see that this actually acts like a Boolean. So the level set mode is set to union. We can set it to difference. So one cuts out from the other. Intersection, so where they overlap. And I don't know what this is. So we'll just go back to union. And then we can... There's nothing really else to change here because this is just putting them together. And then this goes out from the merge volumes into the volume to mesh. And then we can say the adaptive, we can change the detail size here. And this is just changing how it triangulates, so how is subdividing the mesh, I think. We're going to go over to info here and see if we can find what that says. So this is detail size scale. Let's see what it says here. So values below 1 result in more and smaller triangles being generated as compared to the detail size of the input volume. Values above 1 result in fewer and bigger. Okay, so note scale is applied in all detail size modes. So if I go to 2, yeah, so we're getting bigger polygons. If I go to 1, it's not doing anything. If I go to 0.1, does not seem to do anything. What if I go to negative? Okay, it doesn't like that. So we'll just leave that at 1, and we'll go back into our detail size here, and we can adjust things here. So now we can turn off wireframe on shaded. Oops. Let's see what we're getting. And because I animated this and there's still history, I can play the animation, and these things will merge together. So that detail size is quite small. I'm going to change this because we'll retopologize this in the end anyway. So now that we've got something we want, we can actually plug this into the output. So the meshes can go into... That seems wrong because I plugged an output in there before. So I can just tab and just create a new output. I could have used the old one, but just to be safe. So the meshes can go in here, then it will automatically generate a mesh input. And what this creates, so this Bifrost Graph 2 here in the outliner. So Bifrost is separate from Maya. And so what this thing is creating is actually not geometry, even though it looks like Maya geometry. You have to do one more step to get this out as geometry. If you right click on the word meshes here and go to create Maya geometry, and took me forever to find this, but here it is. Create Maya geometry, and I'll hide the Bifrost graph now. You can see this new mesh is created, and it seems to come in without a material, or it always renders this way. I'm just going to go into shading and turn on use default material. I'm not sure why it does that. But now, because this one is still historically bound to the Bifrost graph, which is bound to branch left and branch right, which are in turn bound to the animation on these two curves, we can still play the animation, and this Maya geometry will animate. We can also retopologize this. Now this starts to, if this is a really heavy model, this could be a problem, but for now, just to make it cleaner, and this might be suitable as is, but to make this cleaner, we could go into, I'm going to save my scene, go to mesh and retopologize, and I'm just going to open my options here. This thing is about, I can't read that, 6,000 faces. So I'm going to, it's about, yeah, they're all triangles. So I'm going to change the target face count to like 3,500. And I'm going to increase the topology regularity to 1. By default, it's 0.5. Face uniformity, I'm going to put to 0 and make sure symmetry is turned off. And I can retopologize, right? So you can see it builds a nice clean mesh here. You can see Maya is slowing down because this is actually, there's a lot of steps of history. But if I play the animation now, it's retopologizing on the fly too. So that's why it's very slow. But you can see we get a nice clean mesh that does what we want it to do. If I add a new material to this, just using an open PBR, and set it to something, ketchup, yep. If I turn off use default material, then we can see the ketchup now. And I'll just put a redshift light in here. So I'm not sure this retopologizing is the best thing to do in a case like this where it is an animated model, because it is, I'd say it's probably crash prone. But if we need it, you can see it is working. Famous last words. I'll just create a dome light as well, redshift, and just turn the intensity down a bit. So now if we render this, right, so we can probably play this animation and we can see it closing up like that. So it is kind of a complicated setup, but and actually the the Boolean worked better than I thought it was going to. So maybe the Boolean would work in this case, but when that was just with 2 cylinders. When I did try this earlier with 2 Booleans, when these 2 things were overlapping here, they worked well, but when they separated like this, then I wasn't getting a good effect. So that's why I decided to go to the Bifrost graph to try and replicate that Boolean, but to build it myself with a little bit more control. So just to review again, we've got our input shapes coming in here. Each is going to a mesh to volume. I have a common value node going into the detail size of each. These mesh to volumes both go into a merge volume. The merge volume goes into a volume to mesh. That volume to mesh goes into an output, and then we can right click, create Maya geometry to create a piece of geometry that's native to Maya. And if we don't delete history anywhere along the way, then we can preserve that animation. So again, this is a very simple, kind of safe model. Anything more complex or the animation is more complex, you might run into problems, but try it. This could be useful to solve something that would be very difficult to do with just standard pieces of geometry. Thanks.